Okay, well, hello everybody, and welcome back to Chapter 7, Part 2, Paired Samples T-Test, and this is your SPSS lecture, how to run a paired samples T-test in SPSS. For this lecture, we're going to be using the book data, which is the one that is posted for you online. It's the same data as we used last week. Chapter 7 uses that same data set, which is on page, let me take a look, 93 in your textbook, and this has to do with the zombie data and people's attitudes towards zombies. In this case, let's see, here's our data. This is the same data that we looked at last week. Here are humans, adult humans, scores on this zombie opinion measure, their questionnaire, how they feel about zombies. And if I recall, we have 30 people who took this questionnaire. In this case, we're not going to look at this chased column, but we've got the zombie measure times 2, or second time. And this is the 30 people who took the zombie questionnaire were then all given a zombie rights sensitivity training workshop. So they were given a workshop where they were supposed to learn about becoming more sensitive to zombies' rights. And then every person took the zombie opinion measure again. So person 1, the first time they took the zombie measure, they got a 2. They didn't have a lot of positive feelings towards zombies. And the second time they took it, they got a 2. Remember, we're going to be using different scores. 2 minus 2 is 0, meaning in this case, that sensitivity training workshop didn't change their opinions on zombies at all. Person 2, the first time they took it, they scored a 1. They felt very little sympathy towards zombies. After the sensitivity training, their score went up to a 2. 2 minus 1, that's a 1. So their difference score would be a 1. Their score went up 1 point after the zombie sensitivity training. And each one of these participants, like here, participant 12, started with a score of 9, then did the training, and ended up with a score of 12. So their difference score is 3. 12 minus 9 is 3. Their score went up 3 points. All right, so that's the setup of our data. We're going to go through all the steps of the example in your book, which is page 101 through 103. This is just to reiterate what happened. They measured attitudes towards zombies twice. Once before a sample of humans attended a zombies rights sensitivity training workshop. That's that variable zomb. And once after they attended the zombie rights sensitivity training workshop, that's zomb2. And so we're interested in whether the average attitudes towards zombies before and after sensitivity training is different, basically. Did the sensitivity training work? So we always start with our hypotheses, and in this case, for paired samples t-test, no matter what your data is, the symbols for your hypotheses are always the same. The null hypothesis is the mean difference score is equal to 0. That suggests there will be no difference in attitudes towards zombies before and after the sensitivity training. And the alternative hypothesis, H sub 1, is that the mean difference score is not equal to 0, meaning there will be a difference in attitudes towards zombies before and after the sensitivity training. All right, let's run our t-test. That's always step 2. So let me get over here to our data again. And you can follow along with me. Again, the steps are in your textbook on page 101. I'm just going to turn to that page too so I can, page 101 and 102. But you basically go to Analyze, Compare Means, and over from this menu, you're picking the Paired Samples t-test. So Analyze, Compare Means, paired samples t-test. Here is your paired variables, variable 1 and variable 2. In this case, we have this first one. This is the zombie opinion measure time 1. And this is the second time people took the zombie opinion measure. From my lecture, you remember I was saying you kind of want to put the first variable in, the one that you think will be the larger number, and the second variable, the one that you think will be the smaller number on average. It won't be the case for everyone, but on average. And this is how SPSS will do your subtraction. Variable 1 minus variable 2. And we kind of want our difference score, if possible, to be a positive number. It's just easier to understand when you have a positive number there. And in this case, what do I think? Time 2 zombie will probably be a higher number than time 1. So I'm putting them in that way. You can put them in the other way, and in fact your book has them in the other way. And I can show you that either way doesn't matter, but this is just, I think, easier when you're trying to understand what the data mean. And then here you go. Time 2, when the zombie opinion measure. So after sensitivity training, their scores were 12.80, and before the sensitivity training, 10.267. 30 people in each group. Here are standard deviations. Here are standard errors. We ignore our paired samples correlation. Here's our mean difference score, 2.53. Scores went up 2.53 points. 12.80 minus 10.267. That's your mean difference score of 2.53. Here's your standard deviation of your difference score, standard error of the mean difference score. Ignoring the confidence interval, you go to your T of 13.321, degrees of freedom 29, and your significance of 0.000. Okay, that's the way I would run it. You will get the same data, and I'll just show you, if you put the data in the other way. So it goes back. Your book has the first one first, the second one second. All that's happening is these are in a different order, but it's the same number where before the sensitivity training, the mean was 10.267, and after 12.80, we still have 30 participants in each group. What changes here is your mean difference score is now negative instead of a positive, and your T is negative instead of a positive. What this is saying is that scores before were less, right, it's negative, than scores after. So it really doesn't matter whatever way you prefer. The numbers are all the same. It's just a matter of if you're ending up with a positive mean difference score or a negative mean difference score. That all being said, here's the data. I have it the way that they ran it in your textbook just so you can compare. And that's exactly what it looks like. Your conclusions here. Statistically, you're going to reject the null because your obtained P here of 0.000 is less than the critical P of 0.05. Now, here is an important point. The significance level here is 0.000, and this is telling us what's the chance that you're making an error, right? And remember, there's always a chance you're making an error when you use a sample, like a sample of 30 people, to estimate something about a population. It's always possible you're making an error. What this is saying, the significance of 0.000, if you said your significance value is 0, that's saying that there is no chance you're making an error, which is simply not true. What's happening here is that your chance that you're making an error is very small, and SPSS rounds to 3 decimal places. So it might be your chance of making an error is 0.0000008, rounded to 3 decimal places is 0.000. So you can never, in your conclusions, write that your obtained P of 0 is less than your critical P of 0.05, because P can never be 0. The only way that there is a 0% chance that you're making an error is if you've tested the entire population, which we know we haven't. In this case, we've only tested 30 people. So the convention is when you have data that says your significance is 0.000, you know SPSS is doing some rounding here. It's a very small number, but it's not 0, is to write what I have here. Your obtained P of less than 0.001, that's what we use, is less than the critical P of 0.05. Because it is, we reject our null hypothesis and conclude that attitudes towards zombies significantly increase after sensitivity training with the mean standard deviation that comes right from your SPSS printout, 12.8, etc. Compared to before sensitivity training. Here's your mean, here's your standard deviation. T with 29 degrees of freedom, and I'm using this printout here, is negative 13.321, negative 13.32, P less than 0.05. And the only difference here would be that if you did it, put the variables in the other direction, up here, you would have all the same numbers. Sorry. But your T would be positive. So you can really do it either way, and that's the only difference, is if this was a positive or negative number. Okay, and for me, either one would be correct on a homework or a quiz. So there we go. All right, I hope that was helpful, and good luck with your work this week. Thank you.